So if you need to solve anything quadratic, we usually set it equal to 0, right? Except this is an inequality. So we want to get the inequality symbol to have 0 on one side of it. So I'm going to subtract 15 from both sides of the inequality, just like we do if it was an equation. Because now the logic's a little bit easier. You're wondering when the graph of this expression is greater than 0. So in other words, where it's above the x-axis. Look, this has an a of 1, right? With quadratics, if the coefficient of the squared variable is positive, it's always going to make this type of shape, okay? If it's -2, then it's going to make this type of shape. So if it's going to look like a u, because it's positive, then we're looking for these regions. We want to define that with interval notation, where it's greater than 0. And to find that out, we really need to figure out where it crosses at 0. So to finish solving this problem, we actually want to set this up as an equation. If we solve this equation, we're finding out where that graph crosses the x-axis. I just sketch random places. We need to know exactly where it crosses the x-axis. And you could try factoring. You need to find two numbers that multiply to be negative. Look, I did this times this, right? Two numbers that multiply to be -50 but add up to be 7. How about -10? No. How about +10 and -3? Those multiply to make -30. 10 times -3 makes -30. Those add up to be +7. So we've got our pair. So we're looking for 2x squared plus 10x minus 3x minus 15. Same thing, right? If you simplify it, it turns back into the same thing. I replace that middle term. That way I can factor by grouping. So I look at my first two terms, and I can see I can pull out a 2x from both of them. So I divided both terms by 2, and I've divided both terms by x. And over here you want to keep it positive, keep the leading coefficient positive, so I'm going to divide a -3 out of both of these. And the whole point of doing that, by factoring by grouping, by picking these special numbers, is that you have a x plus 5 in both of the terms. So you can factor out an x plus 5, and that leaves you with 2x minus 3. So hopefully you're familiar with this at this point. This is where you set each piece equal to 0, right? Because if you find out what it takes to make this equation equal 0, then you plug it back in and it makes the whole thing equal 0. So you're going to get x is -5 and x is 3/2 for our two solutions. That's where it's going to cross the x-axis. Okay, and since we know the shape of this graph, 3/2, sorry, not 2/3. Since we know the shape of this graph is going to make a U like this, then we know that everything outside of here is going to, like everything on this interval is going to be positive, everything over here, because it's asking when this is greater than 0. When are our y values of our graph above the x-axis? When are they greater than 0? So it's greater than 0 all the way over here in the x-axis, all the way to -infinity for our lowest number. Then it stops at -5. And look, I'm using a parentheses and not a bracket because it doesn't have the horizontal line underneath. Then it's a union, and then 3/2 was our other place, starting here. And then it keeps going to positive infinity in the x-axis. Okay, the graph might look like it's going vertical, but at some point you can get any number you can imagine on the x-axis. You could plug in 1 billion, and it would still have a dot on this graph. It'd be really, really high. But there's our answer. And I think that's what textbooks usually do, is they put it in interval notation like that.